Alright, trigonometry. It is a brand new branch of mathematics where we are exploring the relationships between the sides and angles in triangles. The relationship between the sides and angles in triangles. Specifically, we're going to be exploring the sides and angles of right triangles.
I think I was really funny back then too.
Take a quick look right over here. In a right triangle, this right triangle, triangle ABC. The side opposite of angle A, the side opposite of angle B, the side opposite angle C.
So we have to get a picture
So,
later.
looking at angle A right over here, the side opposite that, down that way, it's side BC. Side BC right over here. Knowing which side is opposite is going to be key going forward. If you look at this angle right over here, angle B, it'll be this side that is the opposite side, side AC, all the way across. And side C, it's the hypotenuse down that way, side C right over here. I use green for this instead, there we go. That would be side AB. The sides of the triangle. Now, when we're exploring the angles and the sides of the triangle, we will explore and we'll also take note of the orientation where the angles and the sides are in relation to one another. So in this triangle right over here, if we have angle F right over there, that's marked, that's going to be our reference angle. And from the reference angle, we're going to figure out which side is the opposite, which side is the hypotenuse, and which side is the adjacent side. The opposite side is going to be down here. The adjacent side is right over there. Hypotenuse is always across from the right angle. Opposite, right over here, hypotenuse, and adjacent. Might be a good idea to start with the hypotenuse first. Hypotenuse is never going to change. Opposite and adjacent is always depending on what angle we're using for the reference angle, whether it's angle K or angle J. We'll almost never use the right angle for the reference angle. So, start with the hypotenuse right over here on this triangle. Hypotenuse right over here. And if angle K is the reference angle, this side is opposite, that side is adjacent. Now, once we know the opposite, adjacent, and hypotenuse of these triangles, and we know the measures of those triangles, we can create fractions if, let's say, use a triple for this one, 3, 4, and 5. If I want to find the relationship between angle R and the opposite and the hypotenuse from angle R,
where are you seated, dear?
if I put the opposite
Is that your Kate's babe?
over the hypotenuse, there we go, will become 3 over 5. Opposite over hypotenuse of an angle. That's what we call the sine of an angle. You usually see that written down in a calculator as sin. So sine is opposite over hypotenuse. Just rewrite that O right there. There we go.
Yes.
You can also look at the relationship between the adjacents and the hypotenuse. In this case, the adjacent side, that's opposite, that's hypotenuse, that's your adjacent side. The adjacent will become 4 over 5.
Yeah, everyone's here except 3.
And adjacent
So
over hypotenuse, that is your
I told them
cosine.
to mark the check mark in front of their name, and
In the
they went all over
calculator,
the
that's
page,
cos.
So it's a mess.
Okay.
You know, they're 14.
And then there's
Oh,
one
okay.
more where it's
How many
tangent,
kids? Let me see how many we have.
tan,
They cannot.
and that's
take
when
any
we take
technology
the
upstairs to their competition.
opposite
They're gonna have to, so you're gonna get a
over
lot of
the
them manually
adjacent.
and then
So
they're
that's
gonna
going to
have
turn
go
into opposites 3, adjacent is
my
4.
personal life. I think I'm gonna take my personal life.
Your 3 trigonometric ratios, and this is going to be super important: sine,
And if you need a basket to be
cosine,
organized,
and tangent.
Okay.
if you want to do meal
Easy way to
tickets in
remember
there,
these.
maybe, I don't know.
Sine
So
is
how many
always
things do we
opposite
have
over
in total?
hypotenuse.
110.
Cosine is adjacent over
Alright.
hypotenuse.
Oh,
Tangent
and meals are also
is
included in there for
opposite
y'all.
over
and that's
adjacent.
on that same sheet.
Okay.
You guys,
So,
the chaperones
katoa.
are at the very top of that sheet.
Okay.
Okay, thank you
The
very much.
easiest way to remember, and one of the most famous mnemonic devices in all of math, SOHCAHTOA right there.
And where are the lunches? Where are they gonna go to pick it?
They go in the back of that big arena.
Okay.
So if we tried, let's do another triangle, and let's do angle D, and we'll do 5, 12,
Oh, you're
13.
gonna be at Josh?
We're late.
Good luck.
We're going to use angle D as the reference angle.
Macaroni. We have to check here the
Angle D.
chicken tenders. Whatever.
The opposite side from angle D is the 5, which is side EF.
These are cheese pizza.
I'll do it this way, side EF,
Pizza.
in which case I made that 5. The adjacent to the hypotenuse is going to be side DF. I made that 13. The adjacent side is side DE, which I made 12.
They can be anywhere inside.
And if I'm looking for the sine of angle D,
These are
that's going to be
chicken street meal.
5 over 13. If I want the cosine of angle D, cosine is adjacent over hypotenuse, that'll be 12 over 13. And tan of D is going to be opposite 5 over adjacent 12. Now, when we're building trigonometric ratios, remember, ratios is just a fraction. We always want the fractions reduced in its smallest term, and those are already reduced, so we're good there. If we can't reduce it, then we make sure we're able to reduce them. All right, moving on down. So, 3, 4, 5, same idea right over here. With this theta right over here. In geometry, that little 0 mark is called theta, and that usually represents a missing angle. So the opposite side, opposite right over here, adjacent, and hypotenuse. Hypotenuse is always along the side. Hypotenuse is 5, the adjacent side is 4, the opposite side would be 3. And then if I wanted to, let's just say I wanted the cosine of theta, for example, I need the adjacent over the hypotenuse, which will be 4 over 5. Similar idea right over here. We got theta this way now. Hypotenuse is across from the right angle, so root 5 is the hypotenuse. 2 is the opposite side, 1 is the adjacent side. So 2, 1 hypotenuse is root 5. And let's say I wanted the tangent of theta. That'll be opposite over adjacent. That'll be 2 over 1. But that is the way that triangle is built. Sometimes with tangent, you can have the smaller number on the bottom of the fraction as opposed to being on the top. That only happens in tangent, not so much with sine and cosine, but you can see that in tangent. These are just random examples right over here. Say I wanted to look at this angle right over here. Sine goes. We'll go. This since we haven't used sine, we'll find the sine of theta of this one. There's theta, the angle right over here. So we need the opposite side, we need the adjacent side, we need the hypotenuse. Opposite is 5, adjacent is 12, hypotenuse is 13. Sine is opposite over hypotenuse, which would be 5 over 13. All right. So the most important thing, especially when you have right triangles in trigonometry, is to start off by figuring out where your opposite side is, where your adjacent side is, and where our hypotenuse is. In this case, right angle's right over here, hypotenuse would need to be right over there. This is the reference angle, so that's your opposite side, and that's your adjacent side right over there. Same thing right over here, this is your right angle, hypotenuse would need to be right over there. Reference angle's right over here, that's your opposite, that's your adjacent, and so on. Once we have these basics down, we can use trigonometry and sine, cosine, and tangent to solve different parts of a triangle, missing sides, missing angles, etc. And that's what we're going to go on next time.